Hey, everybody. Good morning. Can you guys hear me okay?
Yeah.
Okay. Yeah. Okay. Thank you. Let's get started. I want to review the types of problems and the types of concepts we'll need for the post test for Unit 7. So, just a reminder today we're reviewing Unit 7. Monday, we're going to do the post test. And then we'll start Unit 8 on Tuesday. Also, reminder if you haven't already, today, tomorrow, and this weekend, complete all the mastery tests for Unit 7. I think it's just three. I'm not having you do the unit activity, just the mastery tests. We'll do one of the unit activities coming up, but I haven't picked which one yet. But today, stick with me. We're going to review together on the types of problems from the test. Any questions before we get started? Concerns? Antonio, Andrew. All right, let's do it. Now, the first lesson we did, the first part of Unit 7 is the stuff with parallel and perpendicular lines. So, before we even do that question, let's really quick talk about parallel lines and their slopes and perpendicular lines. If I've got two lines that are parallel, what can we say about their slopes?
They're the same.
They're the same. High five. What about if they're perpendicular? If you don't remember how to say it, just at least describe it how you think about it. If you don't remember like the specific wording.
Wasn't it the opposite reciprocal?
Beautiful. That is the exact wording. Opposite reciprocal. Let's do a quick example together. Opposite reciprocal. So if you are working with a line or a slope of 5/7, what's the opposite reciprocal? The perpendicular slope to 5/7. Anybody? Opposite means change the sign. So pluses have to become negative, negatives become pluses, and then we flip the fraction. So there's two like actions we got to take to make an opposite reciprocal.
Negative 7/5.
Aaron, thank you. -7/5. So whatever the starting slope is, we're going to flip that fraction and change the sign. One more, practicing opposite reciprocals. Starting with, down here in this box, starting with a slope of -3. What would the opposite reciprocal be for -3? What's the perpendicular slope to that? Flip it, change the sign.
Positive 1/3.
Positive, change the sign. And then flip that whole number. Instead of whole number 3, it's got to flip and become 1 over 3. So if it's a whole number, it's going to move down into the bottom of a fraction, the denominator. Thanks, Aaron. Good job. So we're going to need this concept to do the stuff from the first lesson in our test, like question 1 right here. What else might we need for this stuff? We're going to need the slope formula. We're going to rely on that too. So slope formula, if we're just dealing with points and we don't have a picture to like count the squares to find slope, remember, slope is rise over run. And that's basically telling us the change in height. So y minus y divided by x minus x. We're going to need this big time for stuff that deals with the first lesson, because they're often going to give us just 2 points and tell us to basically find the slope yourself. They're not going to tell it to us. So make sure to have that written down. Y minus y over x minus x. That is the slope. That's the steepness of your line. Okay, let's look at number 1 now. A, B, C, and D have the coordinates here, 0, 5, 3, 7, and so forth. So these are A, B, C, and D. Which sentence about the points is true? We can only pick one. We're not going to guess. Let's look at the options. They either all lie on the same line, they're perpendicular lines, they're parallel, they're intersecting, but they're not perpendicular, or A, C, and B, D are parallel. Interesting. So let's start by, since these are all asking us about, all the options are like parallel or perpendicular, basically let's start there by finding the slope of AB and CD, because most of the options are dealing with those lines between those points. So we're going to group together the AB points and the CD points, find their slopes. If they have equal slopes, they're parallel. If they have opposite reciprocal number slopes, they're perpendicular. And that might help us jump right to the answer. So remember, slope is y minus y over x minus x. Always the y is on top for the change in height, the rise. And then x minus x is distance run. And we're going to do AB, and then we'll do CD. So slope of AB. Y minus y. So A is 5 for its y, and B is 7 for its y. So 5 minus 7. And then x minus x, 0 minus 3. Simplify the top separately, simplify the bottom. 5 minus 7, and then 0 minus 3 is negative 3. So we've got negative 2 over negative 3. Simplify that. Negative divided by negative, those both cancel. So slope of AB is positive 2/3. All right, we got to find CD, and we'll compare them. Maybe they'll be the same, or maybe they're opposite reciprocals, and that will tell us our answer right away if so. CD, y minus y. What's that going to be? Double check your numbers. 1 minus negative 5 will work. Or you could do negative 5 minus 1. Okay, as long as you're picking from those the correct points you want, the order doesn't matter how you start with your y minus y. Since I started with 1, then we've got to do 2 minus 6. 2 minus 6. All right, 1 minus a negative 5. Minus a negative. So that becomes 6 on top. 1 plus 5. And then 2 minus 4 is Or I'm sorry, 2 minus 6 is a negative 4. All right, so this slope looks like it's negative 6/4. That can be reduced. So that's negative 3/2. Okay, now we've got our two slopes. Can we make a judgment about the parallel or perpendicularness of these lines?
Isn't that perpendicular?
Very good,
Or is it
Aaron.
opposite?
Yes, what you're correct. They're perpendicular. And how do you know?
Because the 2/3 is negative 3/2 if it was flipped.
Correct. So one slope is 2/3, the other one is flipped and negative. Opposite reciprocal. So therefore, we don't have to find any equations. We're done. We know that they're perpendicular. And there's only one option that mentions perpendicular. So we're done. If we had gotten two equal numbers, we would want to choose parallel for A, B, and C, D. And in fact, I just realized, in fact, if we had gotten two equal slopes, like 2/3 and 2/3, my first guess is let's go with parallel lines. But they gave us this option at the top that they lie on the same line. And before we just jump to parallel, we might want to check and see if they do lie on the same line. Because, if they're on the same line, that means they have to have the same slope. So since they gave us that option A, we would want to make sure that they're not all four on the same line. How would we know? We would need to go the extra steps and find the formula, the y equals mx plus b for each one. We could do for AB and for CD. And then if they come out to the same equation, they would be the same line. If they come out to different equations but equal slopes still, then they're just parallel lines. If we get different slopes that aren't opposite reciprocals, that means they're intersecting, but they're not perpendicular. So every line that you can come up with is basically intersecting unless they have the same slope. So think about it that way. All lines assume that they're crossing, assume that they're intersecting, unless you find that they have equal slopes, in which case um, they're parallel and not crossing. All right. Any questions, concerns, comments? All right, let's look at number 2. Another one that's dealing with parallel and perpendicular lines, okay, from our first lesson. Line AB passes through this point and this point. What is the equation of the line that passes through the origin and is parallel to AB? Oh, something in the chat. Oh, awesome, Andrew. Try this one with me, please. And everybody too. So let's just try to visualize this before we start any math. AB, they're telling us 2 points for it. Awesome. So I'm going to just pretend AB looks like this, just to get a visual. They gave us the actual points, so 3, -2, and -6, 10. Okay, so the direction of my line is not accurate, right? Because those points shouldn't go that way. But if AB is going some way, like this one is, they want to know what is the equation of a line that is parallel to this guy. So it's not AB we're trying to find. It's a line that's parallel to AB, and it goes through a specific point, the origin, which is 0, 0. So let's say AB is floating in outer space here. There exists some line that goes smack in the middle through 0, 0, and it's parallel, meaning same slope, to AB. That's what this question is asking us. And they want, what is the equation, the y equals mx plus b of this guy? So battle plan. How do we start? Strategy. To write the equation for this mystery line, we need the slope and we need the y-intercept. Now, we have the y-intercept because we know it's supposed to go through the origin. What's the y number of the origin? How high or low is that? It's 0. The x is also 0 for the origin, right? It's special. So we already know that the b value is 0. Cool. But we need the slope for it still. How can we find the slope for this mystery line? Any ideas? You can tell me in the chat or with your mic if you have an idea of how we can find slope for the mystery line that they're asking for. Nothing yet. Okay. What information did they give us besides the origin and parallel to AB? What other information did they supply us?
The point.
The points of this another line, right? Or segment AB. Good. They told us that our mystery line, the one we're actually interested in right here, the origin line, they told us that's parallel to AB. Parallel lines have equal slopes. They're both going like up and over or down and over the same amount each time. If we find the slope for AB, that will match the mystery line because it says they're parallel right here at the end of the story. Parallel. So our strategy is find the slope of AB and we're going to plug that into the generic line formula, which is y equals mx plus b. Use the slope, remember that's m, found of AB for our y equals mx plus b for the mystery line. Now we already have b. They kind of told us that indirectly because it's going through the origin. So it's 0 for this question. So this is just a slope problem, but we had to understand what's going on with the question before we even started. So technically, we're just finding the slope for AB and then using that in our formula. So let's do that. Two y's, two x's, and they gave us those in the form of 2 points, A and B. So y minus y, 2 or negative 2 minus 10, and then 3 minus negative 6. Okay, practice with your negatives and positives here. Negative 2 combined with a negative 10, negative 2 minus 10. You're already down 2, and then you go down further 10. So you're a total of 12 down. 3 minus negative 6. Here is where they cancel, okay? Because you're doing minus a negative. You're doing the opposite of a negative, and that's adding. So it turns into 3 plus 6. What is that? 9. So slope for AB is negative 12 ninths. And simplifying that, divide each by 3, negative 4 over 3. Okay, so that's the slope for AB, and it's the slope for the mystery line. So now we have to write the equation, y equals mx plus b. We know b is 0. We know slope is negative 4/3. Remember, when you're writing the equation, we're not actually plugging in anything for x and y. We can plug stuff in for x and y when we're trying to find b or trying to find slope or something like that. but we don't use a number for x and y to show the equation. Otherwise, it's just going to give you a straight line, like a horizontal flat line or something. So here's our equation. We can clean that up because we don't actually show that plus 0. So y equals negative 4/3 x. And one last thing, Edmentum likes to do answers in standard form a lot of the time. So to rewrite the y equals form in standard form, x and y are together on the left side and there's no fractions. So you have to move that negative 4/3 over by adding 4/3 x to both sides. And then we multiply by whatever that denominator is. So 3 times everything will get rid of the fraction. So it's easiest to work in slope-intercept form, and that's why I am using that with you guys. But we do need to be able to convert it and write it in standard forms. These are equal. They're just written differently. They're expressed differently. But they would both make the same straight line. Okay. So again, it was mostly conceptual, and finding slope was all we had to do, and then put it in our equation, our formula for a line. All right, no questions. Number 3. Okay, this is one of those two-parters where they ask us to do 2 different boxes. CD is perpendicular to AB and passes through this point, 512, point C. So we already know that we've got perpendicular lines this time, and we know one of the points on CD, 5, 12. If the coordinates of A and B are here and here, respectively, the x-intercept of CD is what? And which one of these points lies on CD? So, perpendicular this time. A is at -10, -3. B is at 7, 14. CD is perpendicular and it goes through 5, 12. So maybe that's right here somewhere. Doesn't really matter where you put it in your picture, but we know that they're crossing because it says at the beginning they're perpendicular. So they have to be crossing somewhere. So draw your CD in there. You know what? I made a mistake though. I don't think we can assume C is on that line. So let's just put C somewhere floating in space, but make sure we make our line CD perpendicular. So here's C, 5, 12. And we don't know where D is. Maybe it's right here. What's key is that they're perpendicular. So the slopes of AB and CD are opposite reciprocals. And they gave us enough information to figure out the slope of AB. And then we'll use that to find the slope of CD. And we'll need that to answer the first question, which is what is the x-intercept of CD? Where is it crossing the x-axis? So we need the formula for CD, and we'll plug 0 in for x, and that'll give us the first answer. Also, we need the formula for CD to plug in these inputs, plug in the x's, see if it matches with the y in the formula. Only one will work. So again, we're starting by finding slope of AB. So hopefully you remember that by now, what the formula is for slope, y minus y over x minus x. for A and B. Negative 3 minus 14, that's y, and then negative 10 minus 7 for x minus x. Okay, this time all four numbers are negative or being minused. So negative 3, negative 14, those are going to stack up to negative 17. And so will the bottom. Negative 10, negative 7 is also negative 17. So lucky us, this slope is 1. Cool. And we need to write the formula for CD, so we're going to make the opposite reciprocal of 1. This is a little tricky. Remember, do both actions to make the opposite reciprocal. So we flip it, so technically it's 1 over 1, and then you're going to make it negative. But 1 over 1 is 1. So the opposite reciprocal of the number 1 is negative 1. This is the only one, the only number that does this, okay? The other numbers that we try will have an actual fraction for it. This is a special case. So here's the slope of CD, negative 1. And now to write the equation, we're going to use our generic blank formula. Y equals mx plus b. That's the formula for all straight lines. So now we're going to plug in our slope. And they are supplying us with a point on CD from earlier, 5, 12. So that's our x and y we'll use. We're doing this so we can find b, the y-intercept of CD. Not too bad. Whole numbers are good. And we get 17. Weird. Lots of 17s here. Okay, so it looks like this the y-intercept b for CD is 17. So now finally we can write the equation or the formula, the function for CD. The line equation. So CD is y equals negative x plus 17. Now to answer the questions, we've got what we need, the tools we need finally. So we're gonna plug in for the x-intercept. We're gonna plug in 0 for y. X-intercept means where the CD line is crossing the x-axis. So we're not gonna plug in 0 for x. That would give us the y-intercept. So plug in 0 for y to find the x-intercept. So it looks like it is negative x is equal to negative 17. So to get that alone, or simplified, multiply both sides by negative 1, and we get x equals 17. Okay, this is a weird question because all the 17s, but what's important is the process. It won't always be like 17 over and over again. I think this is happening because the slopes they're using are 1 and negative 1. So it kind of makes a special case. Okay, then to answer the second part, we're going to use our equation for CD, and just one at a time, we've got to plug in the inputs of the x's, negative 5, negative 2, 7, and 8, and see which one gives you the proper output, or the y number it's paired with. So just one at a time, we'll try them all. So plugging in negative 5, that becomes positive 5. 5 plus 17, 22, I think. Y is 22. So that does not match. So that means it's not this one. So then you start over and you try plugging in -2. This one's not going to work. We add 2 plus 17, and that's, oh, that does work. 19. That's what we wanted. 2 plus 17 is 19, and that's the output, the y number for that point. Cool. So that means that is the answer. There is a problem like this on the test. It's not the same question, though. I think it's a different numbers. All right. No questions, no concerns, no comments. Please go for it if you do. All right. I think that's it for the parallel perpendicular lines on this review. Now we're on to the ratio lesson. So just a reminder, before we do a question with that, this is the second lesson we did when we're dealing with any given line segments. We're not really worried about the parallel perpendicular lines here. We're dividing up the line segment into different ratios. So if we're supposed to find a certain ratio of this line segment AB, like find the point C that cuts AB or divides AB, into a 4. Oh, that's a weird one. I'm just trying to make an example. Let's say a 4-5 ratio. Find point C that divides AB into a 4-5 ratio. What is that asking us? What does that practically mean for us? What it means is we're cutting up the whole thing AB, the whole segment, into 9 equal chunks. Where's the 9 coming from? It's 4 sections and 5 sections, 4 and 5 together. So cut the whole line segment AB into 9 chunks and count 4 of them, and that would give you point C. We have to use our formula, though, in order to do that cutting in finding the point. But this is conceptually what's going on. So it'd be like taking AB and cutting it into 9 absolutely equal sections. I'm eyeballing this. I'm just estimating. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. So I've cut it into 9 sections. But we can't just estimate it when we want to find an exact point. It's going to be an exact point. But that's where the 4 and the 5 ratio are coming into play. That's telling you how many sections total there are, and it's telling you how to write the proportion that we'll use. So let's see where that would look on here. 1, 2, 3, 4. So point C would be at this location, and they want to know what is the actual X and Y for that. This is the second lesson we did, and this is where we have to use the 2 different equations I gave you. Here they are again. X of C and Y of C, and that would be the X and Y for that special point that they're asking us for. Okay, here they are. Hopefully you've got them in your notes from earlier, but here they are again. X of A, that's the X of the A point. Plus little a over A plus B. And where are those coming from? That's from the ratio. So 4/5 is A to B. 4 to 5, A to B. So for this example, we would do 4 over 4 plus 5, 4/9. And then it's a subtraction for both of these. It's X of B minus x of a. And that's the x of the b point. Okay. And then the y point is very similar. It's just y of a. I'm going to make this capital, actually. Y of a plus the same ratio, or proportion, I guess it is, a proportion, times y of b minus y of a. Ugh. Okay, so these two formulas are all we're going to need for any questions about the ratio of line segments. And then it might take a little detective work to figure out, are they asking us for a point on the line, or are they going to ask us for some other point that has to do with the point on the line, like maybe some off the line point, like point D, but it's going to use the same idea. So let's check out some questions with this. Excuse me. Make sure to have these written down for your ratio problems. And I've got two questions to try about this. Alrighty, in the diagram, the areas of triangle ADC and triangle DCB are in a ratio of 3 to 4. What are the coordinates of point C? So they want to know, what are the x and y coordinates for point C? They're talking about areas, meaning this whole triangle's area and this whole triangle's area are in a 3 to 4 ratio. But if their areas are in a certain ratio, then this line segment, right, from A to C and from C to B, then those are in the same ratio too. So it's kind of a smokescreen and a red herring. What's the right term? Kind of a distraction for them to be talking about areas and for them to be giving us whole triangles. All that we care about is the line segment AB and then point C right here. They're telling us that that's already at the 3-4 ratio. So what's the total of 3 and 4? It's 7. So AB is being cut into 7 equal chunks, of which C is sitting at the third slice. So 4 above it and 3 below it, 3 to 4. Okay, so how are we going to find it? Well, they gave us point A and they gave us point B. That is x of A and x of B. Oops, no, it's not. It's x of A, y of A, x and y. My bad. And they gave us point B, which we'll need too. Here we go. So this is x of B, y of B. And that's basically it. And then we also need to figure out what is the little fraction, proportion that we're going to use in the formula. 3 to 4. That is the little a to little b from the formula. So the fraction is a over a plus b, so 3/7. And from our picture, you can go straight to this 3/7 because the C point that we're interested in, that's at the third line. 1, 2, 3 out of 7 total going up. There's 7 total chunks and we're at the third one. So that's where the 3/7 is coming into this. Okay, so x of C, this is x of A. We always start from the lower one or from the left one, basically, from the A, and move rightwards. That's why the formulas are set up that way. So you start with x of A, which is 1, plus the fraction 3/7 times xb minus xa, so 8 minus 1. Eight minus 1 is 7. Multiply the whole number to the fraction, and lucky us, the 7s cancel. 7 over 7. Because what's happening? I multiply 7 times 3, but before we multiply that, we can cancel ahead of time if it lines up, and it does here. So those are gone, and now it's 1 plus 3, which is 4. Woohoo! So x of c is 4. And now we need to find the y of it. So y of c. So this one starts with y of a, which is negative 9. Same fraction, 3/7. And then it's going to be y of b minus y of a. So what is that? Negative 2 minus negative 9. Okay, don't forget minus negative 9 turns into plus 9. And it came out to a 7 again. Very cool. So those cancel again, and we've got negative 7 plus, or sorry, negative 9 plus 3. So that is what? Negative 6. That's the y of c. So these questions are, I think, honestly, a little less less troublesome because as long as we can figure out what our fraction is that we're using, 3/7, that comes from the ratio they'll give you. Then we're just using those two formulas to find the point at that location. So there's not too much thinking that we need to do, or as much thinking as the previous questions, where there's a lot of concepts in the parallel perpendicular problems. Here, we're basically just plugging and chugging, putting in the numbers into the formulas and simplifying. All right, no questions. We've got a little less than 20 minutes left. Let's do another one of these. All right, the picture looks a little more complicated this time. Before we even read the words, the line that we're probably going to be dealing with mostly is AB again. How do I know? Because it looks like our other diagrams for ratio of line segment problems. It's a straight line AB, and then we've got point Q hanging out on it. So Q is probably going to be a certain ratio on AB. Let's find out. In the diagram, PR and AC are vertical. PR going up and down and AC going up and down. Check. CB is a horizontal line segment. Terrific. If the ratio of CR to RB is 2 to 3, what are the coordinates of point Q? CR is this segment, and then RB is right next to it. Ruth Bader, RB. Ruth Bader Ginsburg. Miss you. So then this is 2 to 3 down here. And that does correspond to the segments above it on AB. So that means Q is sitting at a 2/3 ratio along AB. So they're telling us the same info, but they kind of, kind of hid that. They made it indirect. They didn't directly tell us that Q is at a 2/3 mark along AB. And it doesn't look like it's 2/3 along AB either. They're basically saying that it would be, 2/3 looks like it should be way lower, closer to B. But whatever, we're going to use this setup and solve for Q. So the picture doesn't really match reality, but it is supposed to be 2/3 of the way along. So it should be a little lower, like here. but it's the same type of problem. So find point Q. So xq, it's the same formula as what we've been using for xc. We're just calling it q this time. So starting from a, 2/3, b minus a, x's. So what's 1 minus -4? That's the x of b minus the x of a. Plus plus. So 1 plus 4 is 5. Okay, this is not going to cancel like the last one did. So 2 times 5 on top is 10/3. And then if we need to add a -4 and 10/3, how do we add a whole number to a fraction? We have to have our whole number in the same units as the fraction, the same denominator. So to fix this, we multiply our -4 by 3/3. And then it's in a fraction form with a 3 at the bottom. So -12/3 plus 10/3. So that's -12 plus 10, -2/3. So there's the x of q, just like how we found x of c. So it's -2/3. And if it's in a decimal in Edmentum, all you got to do is divide the fraction. So 2/3 is 0.66 repeating forever. 666. There we go. And then we're going to do the same thing to find q. Two-thirds, and then it's y of b minus y of a. So what is that? -7 minus -2. -7 plus 2. What is that? -5. Interesting. We got a 5 last time, and now we got a -5. Keep going. -5 times 2 is -10. So we already converted the 4, or no, it's a 2 this time, though. So we've got to multiply our -2 times 3/3 to add these together. -2 times 3/3 minus 10/3. So here we're going to have -6/3 minus 10/3. Goodness. So this is going to be -16/3. -6 minus 10. -16/3. Terrible location. But there it is. And then if to find the decimal, divide 16/3. 5.3 repeating. Same process. They gave us the ratio in the story. It wasn't directly saying Q is at 2/3, but they told us that these chunks were 2/3, which correspond to the ones above them here and here. So that is indirectly telling us Q is at the 2/3 mark. Oh, snap. I can't believe it. Actually, I can totally believe it. I made a pretty good mistake. I wonder if anyone caught it. I'm not going to redo the entire problem, but I made a mistake when I made my AB fraction. It's easy to do this. So look at the AB fraction I used. 2/3. This is an easy trap to fall into. 2/3. Is that the correct fraction I should have been using? Remember, the formula is A over A plus B. So it's not 2/3, it's 2 over 2 plus 3. 2/5. Darn it. So be aware of that when you're doing this tomorrow or later today if you do the test early. A over A plus B. So the process is correct. I just used an incorrect fraction for my formula. Should have been A over A plus B. So be aware of that when you're doing yours as well. It's an easy trap to fall into. I did it. You could do it too. And check it out. Since it was 2/5 was the proper fraction, then actually the 5 and the denominator would have canceled again in both cases if I had used the correct fraction. So whoops. That was not on purpose. But it is a good learning experience for me, hopefully for you too. Be aware of setting up that formula. There's 2 more problems I wanted to do with you guys. It's what we did yesterday, finding area and perimeter. So these are probably the easiest ones that we did for this unit, the next problems. Before we do that, any questions, concerns? Just so you know, the test is short. It's like 12 questions. So I think it's 4 from each lesson. Okay, I picked one of the harder ones of our area and perimeter. I wanted to do another one of these generic ones where they don't actually tell us the real numbers that are making the triangle. They have it in terms of x1 and y1, x2 and y1. But if we use our formula for area, we should be able to add up everything and find the area. So remember, area of a triangle is 1/2 times the base times the height. Now, when it comes to finding the base, you can use any side you want. But always, I would say, always pick the side that's like either vertical or horizontal because you can easily measure that. And if you do that, then the height should be easy to measure as well. So if we use the top side right here of our triangle to be our base, then that makes this segment down to the point at the bottom our height. So we have to be flexible and malleable and rotate that triangle around, at least in our mind, to choose our base and our height. Now we can't count squares because we don't know that x1 right here, even though it's at the second square, we don't know if that really represents -2. Okay, if it did, they would tell us it's -2. And we also likewise y1. It looks like it's 3 squares up. I understand that, but it's not representing 3. We don't know what it represents. So frankly, they shouldn't have even had these grid lines in here. Those don't belong here, but they're going to be there on the test. So how do we find the length of the base without being able to count the squares? Well, they didn't tell us the numbers for x1 and x2, but we are calling them x1 and x2. So the length of it will be the farther one on the farther rightwards one minus the leftwards one, x2. So the length of base is one side minus the other, basically. I guess we could do x1 minus x2. Let's try it from the more positive looking one minus the more negative looking one. So x2 minus x1. Honestly, either way should work. but I guess we could get a negative if we did it the backwards way. So there's our length of the base, and the height is, how high is this? We know it's being marked as y1 down to this location, which is being told is 0. So y1 minus 0 is the height. And what is minus 0? It's just the other number. Y length of height is y1 minus 0, but y1 minus 0 is just itself. So it's just y1. So there's our base, and here's our height. So the area of this whole triangle will be 1/2 times x2 minus x1 times y1. And as complicated looking as all those options are, as long as you use the correct formula, area, we should be able to find one that matches what we wrote. Remember, the order of multiplying doesn't matter. Okay, I've got one more problem, and we've got like 2 minutes or so. Let's try it. Oh, I don't have one more problem. That's it. Cool. So we didn't do one of the easier ones, but anyone who was here with me yesterday or watched yesterday's video, you should see that most of these problems, when they tell us the actual numbers for the points on the triangle, it's just a matter of adding up the squares to find the lengths, and then we're using our perimeter formula and our area formula to find perimeter and area. If it's a diagonal line, folks, like this one, I'm going to color it right here. We can't use squares on a diagonal, so we do have to use the distance formula. And for those ones, they usually do give you the real numbers. So distance x minus x squared, excuse me, plus y minus y squared. And you have to take the square root of the whole thing, and that's the distance formula. So just remember, any diagonal lines, you have to use distance formula. Any horizontal or verticals, you can just count them using the units if the numbers are actually given. This problem, they weren't. All right, someone dropped out. Have a great day. If you want to try the test today and try it early, go for it. Otherwise, we're going to do it as a group on Monday morning, okay?
Bye, Josiah.
Bye, Manaya.
Okay, bye.
Bye, Aaron. Thank you.
Have a good day.
You too, Braden. Bye, Maria Celeste. Thank you. You too, Andrew. Thank you. And Keegan.